This is Geometry, Chapter 2, Section 3, in which we will study conditional statements. Last time we talked about statements having a truth value, either true or false. These statements, conditional statements, are statements that we would write in if-then type form, and they may be true or they may be false. It kind of depends. That's why they're called conditional, because it depends on the condition of the two parts. The two parts of a conditional statement are called the hypothesis and the conclusion. The if part is the hypothesis, the then part is the conclusion. So one of the things you're going to be asked to do here is you're going to be asked to identify the hypothesis and the conclusion for each statement that they give us. So if a polygon has 6 sides, then it is a hexagon. The hypothesis is a polygon has 6 sides. Typically, they like to use P for hypothesis, and they like to use Q for conclusion. It is a hexagon. Now, technically speaking, I want you to notice here, if and then don't appear as part of your hypothesis or your conclusion. Okay? The statement says if a polygon has 6 sides, but your hypothesis is just that a polygon has 6 sides. Kind of nitpicky, but that's how logicians are. Here's another statement. Another performance will be scheduled if the first one is sold out. They're being tricky here because the if is hidden at the back. Typically the conclusion is at the end of the statement, but sometimes they like to be tricky and they throw in the conclusion in the front. So our hypothesis would be the first one is sold out. Our conclusion would be another performance will be scheduled. Okay. A little bit tricky sometimes the way they like to word things. Sometimes they don't even put if or then in the statement. The last one didn't use the word then anywhere, but we were able to figure out the conclusion. Sometimes they're not even going to mix it in at all, and we're going to have to work to figure it out. The way you figure out where the hypothesis is and where the conclusion is you have to remember that the conclusion always depends on the hypothesis. Another one of those important things that's in red and I'm making it blink at you on the screen must be important. Conclusion always depends on the hypothesis. So they're going to give us some statements that are written not in conditional form. They're not written as if-then. And we have to figure out where our hypothesis would be and where our conclusion would be, and then rewrite it so that it fits the if-then description. So our statement here, the sum of the measures of 2 supplementary angles is 180. What has to happen for us to even be able to talk about this? We need to have 2 supplementary angles. If we don't have 2 supplementary angles, I could care less if the sum of their measures is 180. Okay. To be able to get to 180, I have to have 2 supplementary angles. So that's the hypothesis. The conclusion then is the sum of their measures is 180. So now to rewrite this in conditional form, if 2 angles are supplementary, then the sum of their measures is 180. Okay. We broke it down. We figured out what we needed to have happen first. We had to have 2 supplementary angles before we could even talk about this problem. And then the conclusion would be their sum is 180. So then we rewrote it. If 2 angles are supplementary, then the sum of their measures is 180. Okay. Now, like I said at the beginning, conditional statements also have truth values, just like having truth values for the individual parts. Now, something to remember when you're determining whether a conditional is true or false: if you cannot determine that what you're looking at is false, then you have to consider it to be true. So let's consider this statement, or these statements, and see if we can figure out the truth value. And if we can say for sure they're false, we need to know why. So our first one, if next month is August, then this month must be July. Okay. If next month is August, well, what's the month before August? July. So that is indeed a true statement. If next month is August, then this month is July. That's true. Consider the second one. If angle A is acute, then its measure is 35. Angle A is acute. That means its measure has to be less than 90. But nothing says it has to be 35. So that's false. Angle A could be 40. Angle A could be 88. It doesn't matter. There's just nothing that says it had to be 35. So we could tell for sure this one had to be false, because there were possibilities where it would be false. If A is 40, it's certainly not 35. When we write our conditional as if P then Q, and words, that's how we would write it, if P then Q. In symbols, you write P implies Q. You put an arrow, P leads to Q. Knowing that P is true tells you that Q is also going to be true. Okay. And often in logical arguments, it's not just the conditional statement itself that you're interested in. There are 3 other statements based on that conditional that are important. And you're going to spend a lot of time writing these statements over and over to get used to what they mean. The first related statement is called the converse. Now, we're not talking about the basketball shoe. The converse of a statement is formed by exchanging the original hypothesis and conclusion. So instead of saying if P then Q, we would turn it around and say if Q then P. In the last statement that we had, the converse would be if its measure is 35, then angle A is acute. Okay, we would switch their places. Symbolically, that would be Q implies P. So the converse, we just flip-flop their places. The second related statement is called the inverse. The inverse is formed by negating both the original hypothesis and the conclusion. So instead of saying if P then Q would be the original statement, we would say if not P, then not Q. Symbolically, that would be not P implies not Q. That would be the inverse of the statement. So considering again that last one, the inverse would be if angle A is not acute, then its measure is not 35. Okay, sticking that not in there to negate those. Then the last one is the fun one. It's called the contrapositive. And to form a contrapositive, you do both things. You exchange the hypothesis and conclusion, and you negate them. So you do both. You trade their places, and you throw nots into them. So that would be, if not Q, then not P. Or symbolically, not Q implies not P. And you're going to get some practice rewriting statements into their converse, their inverse, and their contrapositive, and then figuring out truth values for them. And as it turns out, the original conditional statement will have the same truth value as the contrapositive. The converse and the inverse will have the same truth value also. Those two together will be the same. They may or may not be the same as the other one. The converse may not have the same truth value as the conditional, the original conditional. But the converse and the inverse will have the same truth value as each other. So let's do one of these, give you a little practice here before we sign off for the video. Our conditional statement is, if a polygon is a rectangle, then it has 4 sides. I think we'll all agree that that statement is true. If I'm looking at a rectangle, then I can see it's got 4 sides, so that would be true. The converse of that statement would be, if a polygon has 4 sides, then it is a rectangle. Well, that's not always true. You could draw a polygon with 4 sides that is not a rectangle. So the converse in this case would be false. The inverse is you put a not in there. So if a polygon is not a rectangle, then it does not have 4 sides. Well, again, that statement is false. I could draw a polygon that's not a rectangle, but it would still have 4 sides. Okay, a trapezoid comes to mind. It's still got 4 sides, but it's not a rectangle. Notice converse and inverse both had the same value. They were both false. And lastly, let's look at what the contrapositive would look like. That's going to be reverse the P and the Q, switch the places, and also put knots into it. So in the contrapositive, our statement would be, if a polygon does not have 4 sides, then it is not a rectangle. Well, picture a polygon that doesn't have 4 sides. Might have 3, might have 8, whatever. No matter what other number of sides it has, if it doesn't have 4 sides, there's no way in this world it can be a rectangle. Because rectangles have to have 4 sides. So that part, that statement, the contrapositive, would be true. So we're continuing our work in logical arguments. We've added in pieces of conditional statements, hypothesis, conclusions, and then the 3 related statements, the converse, the inverse, and the contrapositive. As always, if you had questions, hopefully you jotted those down. Bring those in with you, and we will see you in class.